Hi, all, Bones here from BSA Bantam. So if you can hear the noise, it's my diesel heater warming up the shed because it's a little bit arctic in here this morning. In this video, I decided to do a video on machining those triple clamps up and fitting that all up. So let's go and have a look. So I have both of them fly cut underneath, and we've just changed the setup, and we'll just fly cut the tops of these. Just gives it a clean up. This is the top triple clamp. So we've got 1 millimetre to take off there. So first one off the milling machine, I'm just dressing off the edges, not for cosmetic reasons, just to remove the burrs so I don't cut myself. This has had a minimal cut off the top here, 1 millimetre, and still no signs of porosity or anything like that. There's a couple of pits in there. That's from the surface finish. It's not from the actual material itself. So I'll finish deburring this one, and we'll get the other one set up in the mill, and we'll face that off. Okay, you can see we've got it set up clamped in. I'm about to take a touch mark. That'll give me, well, actually just take a touch mark and go through to make sure everything's parallel. So I'll just wind it down and I'll start cutting. Lock up the table. So I just winded the tool back down, so I've got 1/2 mil to take off this one, and we'll be at the right width that I want. But it's cleaned up nicely. Once again, this one doesn't look like it's got any porosity in it. Over the back there, where there's a little bit of a defect, you can't really see it, I'll turn it around. Around here, I think what's happened is that when I was putting the two moulding boxes back together, a little bit of sand's broken off and fallen in, and that's what that is. Make sure the tool's clear before I wind it down. 1/2 mil on the digital readout. Actually, we'll go 0.4, and then I do a finishing cut of 0.1, just to give it a really good surface. Okay, as you can see, I've machined down the undersides. Didn't quite clear up that little depression. I reckon another millimetre and I would have got it. And we've machined these top surfaces here on both. Now, this little pouring gate here not only acts as a clamp surface when I bolt it down to the milling machine, I'm actually going to drill and tap a hole through there and put a bolt through there to keep these parallel and in alignment. So this is our top clamp. So when I put it on the milling machine, I can put parallel strips underneath there, clamp, and then do all my 3 holes without moving the setup at all. So we'll have to go through. I'll have to blue and mark it out after I clamp these together, but we'll get stuck into that. So I've just drilled a hole through here, M6, socket head cap screw and nylon nut, and we'll clamp these together. And there you have it. So I will now go on to bluing these off and marking them out. I don't have a datum surface, so I use my milling table with my height gauge to mark all this out, but we'll get onto the marking. Oh, this is a bit tight. So what I'm doing now is just a bit of marking out glue. thick too. There's a bit of metho in it. So my reference point, like it's a little bit, not hard to mark out from casting. So effectively my datum point reference will be the center of this hole, because obviously I've got those at a certain distance. So I'll mark out and pick up a center here, use that as our datum reference and work out in either direction from there. I'll just give this a bit of a lick off on the side with the linisher. I'll stand it up and use the vernier height gauge to mark my distances. It'll also give me a reference to work from for that distance there. I can basically pick up the centers pretty accurately, and then it's just the actual distance for the boring the holes for the forks and its relationship to where the head stem bearings are going to be. So I'll let that dry off and we'll start marking out. Okay, hopefully I'll try and angle the camera down so you can try and see what I'm doing. I'm sure there's lots of ways to go about doing this, but basically the way I was taught in my apprenticeship by an old Hungarian bloke, you basically pick up, scribe around so you nearly make a square, and then you go back so I don't know whether you can see that, probably not, but anyway, I basically effectively got a square in there. Just bear with me while I grab my scriber and a rule. So I'm picking up the corners of this square I've scribed. Okay, I've got a center. Now what I'll do is I'll just get my dividers. And what I'm doing with the dividers is just verifying that I am in the center. So I'm just going over to the edge of the casting, around that side, that side, that side. And actually I'm not. So that's on the edge there. It's about 1 mil off there. It's about 1 mil off there and 1 mil off there. So I'm pretty happy with that. As I said, it doesn't matter because it's a relationship between here and centralising your forks with the centre line of your head stem. That's going to be critical. So I'll get my angle plate up on the milling machine, clamp this up to my angle plate, and then get my vernier height gauge out. So I've got the centre line marked for the actual head stem itself to come through. It's just off camera here. I've just zeroed my height gauge, and now we've got to go, what was it, 96.5 mil to get the center line of the top one. So we just undo the clamp, so I'll slide this up. All right, nearly, well, I have made one mistake, but I nearly made another one. So the drawing I was working off was the drawing for the pattern. Now the pattern's got to be 7% bigger than what the finished product is, because once you pour it, it shrinks. The other thing too is I've marked it out on the wrong side because I want these surfaces to be able to be my machine surfaces to mount everything up, like, and clamp it down onto the table, nice and squared in relation to everything. So I've got to mark it out on this surface. So you've seen how I've done it before. I won't show you this one. I'll just go and mark it out. But anyway, it's all good. So I've got the right drawing. And I'm just marking out my top one. So we've got to go 92. So because I zeroed it here, I can go 92 in the negative for the bottom one. 80. 93, just up a fraction, adjust it up. .92. Rightio. So now I know I'm absolutely equidistant from our datum point, which is here. So we'll get these marked out. We'll do the setup. So I will be lining up, drilling and boring the one hole while everything's absolutely in alignment. So we'll get that set up and we'll get a start on that. So I've just set up on my parallel strips. Parallel strips are on the handlebar mounts, and just nipping this up. And I don't think that's going to go anywhere. I'm just having a look underneath, make sure my parallels aren't moving. I make sure I haven't got any gap there that's rolled it or anything ridiculous like that. So that's looking really good. So that setup will stay like that to drill and bore each hole in relation to each other. I don't know whether you can pick it up. I've actually marked circles out on here. That's not the finished diameter. That's just to give me a bit of a reference for roughing it out. So I won't really measure. I'll just bore it out to those lines, and then I'll start my precision measurement and get everything right. So time to change the setup on the mill, get it up high enough so I can get drills and boring heads and all that sort of stuff through. So what I'm doing now is I'm lining up for my first hole. So I've got to have enough distance in there to not only fit a boring head and the actual tool, but also another drill bit in here. Excuse me. So I'm using tiny little center drill to get my alignment. And once it's all aligned up, I'll lock everything up, lock the table up so it can't move, go and drill and bore this out. So I'll turn the camera off because it gets a bit noisy with the mill going. So I've got our center drill. So I'm just about to drill a pilot drill to start it all off. So first minor problem, can't fit the boring head in. So much as I didn't want to, I'm going to have to lift the head up. It's all right, I can realign it with the drill bit down the hole and that'll be fine. So we've got the boring head set up and we'll give that a go. I think this might be a fraction too quick for it, speed-wise, but we'll see. That's pretty good. Okay, so if you can, that's the back of the boring bar there, and I'm not getting a very good surface finish, as you can see. And what's happened is, because I've actually rotated that tool around in the holder up here, the back of it's rubbing. So I've got to linish off a bit of a relief in the back because it's getting a bit of aluminium build up on there and just stuffing up the surface finish. So, and you can feel it by the temperature in it, that it's rubbing and not cutting. Positive rate tool will take the heat out of it with the chips. So I'll linish a bit of a relief on the back of that and see how I go. So that's a lot better on the surface finish, but not as good as I want. That's shiny on the back because that's where I linished the back of the tool off to give it a bit more clearance, and that's working really well. So I'm going to take I've got plenty of meat on. Like I've got probably 10 mil to take out of that. But I want to find out whether this tool will actually give it a really good surface finish at the end. So I'm only going to take something like a 0.1 or 2 cut. I mean, basically at the moment, I'm probably ripping out about 4 to 5 mil out of the diameter at a time. So, and that's actually cooled down, which is a good sign, which means the tool's cutting nice and sharp, or tool is nice and sharp and cutting well. So I'm just going to try that tiny little micron cut and see how the surface finish comes up. Because I'd much rather find out now before I get to close to size. So I've got a lot better surface finish. I've sharpened the tool. I've actually changed it from a positive rake to a 0 rake, this being cast, and it seems to have worked really well. I'm pretty happy with it. So we're nearly out to our witness mark, the circle I scribed in there, so it's time to start measuring and getting it a little bit more accurate, getting down to finished size. So we're getting a really good surface finish. What I'm doing now, and I know my hand's in the way, but I can't help it, my apologies. I'm just measuring the bore, and we'll start adjusting accordingly on the boring bar to get our finished size, which what I want is 32.1. So the forks are 32. I want, because these are going to be split and be able to be clamped, I want a little bit of clearance to be able to get the fork in. I don't want it to transition fit. And with my failing eyesight, that's 29.43. So what I'll try and do is adjust it up to get to 30, and I'll show you in a sec how I'm going to achieve that. So when I'm doing jobs like this, I do not trust the graduations on this, and I've got to go that side, on the actual boring bar. And actually what I'll do is I'll try and turn this around so you can see what I'll turn that through 90 degrees. Lock that up. Oh, I've got to lift it up. Wind that down a bit. Right. So you can see the dial indicator there. It's not very square. Wind that down a bit more so I can get my dial indicator nice and square. That looks better. So, right, that's looking all right. I'm going to put that around to 0. And the boring head is already locked up. I haven't undone anything here, so I'll undo that. So, what did I say we're at? 29.43, I think. I'll just measure again. 29.43, so that's 5.57 I want to come off. Now, this is measuring, you're cutting a bore, so this is cutting off the radius. So I want half of that. So we'll go 56, which is 0.28. So I'm just going to unlock it. And I want to wind that out, 0.28. Right, so if I lock that up and it moves, well, I've got to unlock it, and it's gone half a hundredth of a millimetre, which is sort of what I want. Not sort of, it's exactly what I want, because that'll give you the 57. So I'll machine that out and see what we end up with. Right, I've just finished cutting, so we'll measure, and I was aiming for, take it to 30 millimetre diameter. and we have 29.9, which is, or 29.99 I should say, which is fine. Like that's half a thou in the old bananas terms. So I'm happy with my surface finish. It's all going really well. So only a couple of mil to take out now. So I will do that in 0.5 millimeter increments and see, hopefully it will maintain the cut all the way through with the same tool pressure. And that's the reason, you know, I stop a couple of mil out, have the same depth of cut all the way and see how consistent it is. So we've just taken basically a 0.5 millimeter cut. It was within 0.01 of a millimeter. So I'm hoping the rest of them will be all right. So if we drift off just a little bit, you know, I've got room for adjustment. Having said that, this, I mean, you know, this isn't absolutely critical. You know, if I end up, you know, a couple of hundredths of a mil out either high or low, it's not going to really matter. But I mean, the whole point is aim to get it spot on. It's good practice all the time. So when you do have to do something that is that accurate, at least you're confident that you can do it. Right. Dial indicator back on. And I'll start adjusting up and I'll get this finished. So I'm getting ready to take my final cut. I've got my dial indicator set up. My wife just came in and interrupted me. So I lost my train of thought there. So the fork legs are actually 32.95. So I'm aiming for 33.05 and we're at 32.52. So it's 26.5 or 0.265. So 1, 2, 6, and one more. I've actually done it at 27, which is fine, because if anything, I wanted a fraction bigger than smaller. So we'll run that in and see how we go. I have detected a few little bubbles in it, but nothing terrible. It's no worse than a commercial casting lock on a pulley or something like that. So I'm pretty happy about that. So anyway, we'll get onto it. All right, moment of truth. So we're aiming for 33.05. And we've got 33.06. So 0.01 of a millimetre off, which is fine. It's well within the tolerance that I wanted. So got a good surface finish, very happy. No real porosity to worry about there. There are a few little air holes, but here and there. But all in all, very happy. So time to go and do the other one now. So I won't bore you to tears with doing that, and I'll bring it back when we've got a bit more done. But very successful. With the head stem, you need like a nut to tension it, and then a lock nut. Now the original Bantam one's not really going to work, and I do want a chrome covered one. So I was thinking about it, and I went out to the kids' Chinese pit bikes, and they've got them on. So they cost bugger all. It's not worth my while buying the lock nut and the nut when they're about $8 or something ridiculous like that. So I've ordered a couple of those to come in, and I will make the actual head stem itself to suit. So it'll match the Bantam head stem bearings, but I'll cut the metric thread on the end. So on the bottom triple clamp, I'll do a counter bore, and that shaft will be shouldered, so it'll press up into a counter bore in the bottom of this, and then everything, the bearing and everything will stack on top. Anyway, that's enough of that. I'll go over and get this other one bored out. Okay, so what I'm doing now, I've just got the burr on the die grinder, and I'm just starting to knock off all the actual casting, get this surface. I'll go back with a sanding drum and just clean this right up, so that way it'll be really good and nice to mark it out and spot it and everything like that. So we'll keep going. I don't know whether you can see that, but I've marked out for my through holes for clamps and counter bores, and also for the center line for cutting it. So time to get it up on the milling machine, get it all set up nice and straight, and get into it. I am hoping you can see that. I am just lining up my slit saw to cut the slot all the way through. Which is a little bit challenging. Here we've got to go down a fraction more. So because I've run out of travel going that way, I actually have to plunge it in, then cut across. And you can't see around the angle plates. I've only got 5 or 10 mil clearance, so the blade's just got to go in, and then we'll feed across. And the camera's right in the way, so I'll move it. We'll give it a go. So that's our first slot cut. Wouldn't say it took a little bit, it's just had to be a little bit ginger about feeding it and everything like that, but it's gone well. So I've got my slot cut. What I'm doing now is using the center drill to get my alignment with the marking out that I've done, and then I will spot it with a 12mm slot drill, not an end mill, an actual slot drill, milling cutter, and spot it down to get that nice and flat, because it's right on the edge of the curve and I don't want any drill wander. So I'll spot it flat, re-center drill it, then go through with the chap and drill, clearance drill, and the like. So we'll get this lined up. Oh, not fast enough, got to change the speed. So I've got my end mill in. Now I've actually got one that's, most times you use a 2-fluted slot drill because it'll cut the center out, but this one's actually set up to be like a slot drill as well. So that's why you wonder why I've got a uni mill in, that's why. And that's exactly what I wanted. I'll try and bring it in. I can't bring it too close because it doesn't really focus, and it's probably out of focus now. But I'll change back to a center drill in here now, and then start drilling all my holes. So we've got our tapping size hole drilled in the bottom here. We've got a clearance hole in the top half here. It's spot face, it's been deburred. I'm just about to run in with a spiral flute tap and start tapping it out. So cutting compound I use, it's kerosene. So here we go. Now this is a spiral flute tap, so you don't have to keep backing out to break the chip. So I've been busily working away. and we've got the castings, I'd call it dressed. They're certainly not ready to put over the buff yet, so they have been filed, sanded with emery, bit with the die grinder, and now I'll get into it with some wet and dry and start to really finish it off. So what I'm starting off with, wet and dry grade, is 400 wet and dry. This has got detergent in it. I just find having a bit of detergent in with the water when you're using a wet and dry, it really makes it cut in really well. So I'll go from 400 to 600 to 1200, then I'll put it on the buff. So I'm sure you don't want to watch me for 3 hours rubbing wet and dry on this, so I'll bring you back later when I'm ready to put it on the buff. So we've sanded them down, plenty of wet and dry and other stuff, so we're getting ready to buff. I'm pretty happy. It can't quite get in around this boss here, so I'm going to leave it anyway. It'll be fine. So we're going to stitched wheel first, and then we'll go for the mop. Just cleaning the old rouge off. And we'll get stuck into it. So I've just finished with the stitched wheel. So I've just got some degreaser and I'm cleaning all the coarser rouge off, and now I'll put the mop on. We'll give it a final polish and see how it comes up. So that is the job done. And I've only snugged these screws and I can't turn it, and I'm like putting basically no tension on it, so it's a good fit. They just it's a perfect fit. They just, you know, just twist them a little bit and they just go straight in without forcing them. So yeah, pretty happy with the outcome. Mind you, it's 3 full days work at those, but it's exactly what I wanted, and I needed it for the distance apart, and because the hub and the actual geometry of the clamps, I wanted it set up like that, because actually it's a Bantam here. If you look at the Bantam here, that's your head stem and your forks away out there. So I wanted it further back in alignment with the actual head stem. This is this is a customer bike that's come in. Engine rebuild and a few other little jobbies, electrical and that sort of thing. So we'll get onto it probably next week. So yes, I'm pretty happy. I think they've come out pretty good. Okay, another job on the Celix Racer done. So I've got to still make up the spindle to go through here. The only issue I had was, if you remember from last, the actual casting video, because I had a slight depression in the back of the casting, I'll put a little counter bore in, and I'll put a little like a steel top hat bush, so that will sit against the top bearing, because I need a full contact area to keep it square. But that's not a big one. I've done the counter bore and everything like that. Thank you to all my subscribers, old and new. We've rolled over more than 1,500 subscribers, which is really great. Never in my wildest dreams did I expect to have that many subscribers. So obviously there's a few people out there that like what I do, so I'll keep doing it. I've had the hubs blasted. I've got to paint them, and I'm looking at. I'm in contact with a guy who's a wheel builder about actually building the wheels up rather than me sourcing spokes and all because it's a mismatch. Like the alloy rims are different to Bantam size rims, so I'll probably end up sending them off and get those done. Next jobby will be, as I said, the spindle, getting this front end onto a frame, and then we'll start doing things like fitting up the tank. And it's not a standard Bantam tank, I'm using a smaller tank, so I've got to see if it'll work, and I might have to weld brackets and all that sort of stuff. But anyway, thanks very much. I really hope you enjoyed the couple of videos I did on these. For those people asking questions about lost foam casting and the heads, yes, I'm still getting heads machined. The mate who does it is away, so he's going to machine a couple more heads for me, and we'll have another crack at that as well. I'm determined not to be beaten. So we'll definitely be doing that. So from me at BSA Bantams, thanks very much for watching, and we'll see you later.